Thank you for joining. My name is Eric Neunaber. Last name is easy to say, kind of hard to spell. But I work for Worldwide Technology here in St. Louis, Missouri, and I help run part of our cloud practice. And I'm going to talk about Kafka today. So I got the title Thinking of Events First from a talk that was hosted by Confluent. I thought it was a really catchy title, so I stuck that in there. So I have this idea that I'm going to make it big someday, and I kind of realized, like, I'm getting old, right? There's maybe a little less time, on my clock to do something really big with my life, but I think this is the moment, right? I'm really going to do something, and I like my day job. It pays well. I like the people I work with. But there's just this notion of, like, maybe if I'm my own boss, like that's how I'm going to do it. I'm going to do something big if I work for myself. And so, as I sit here and ponder, like, the different things that I can do to make it big, I like what I do for a career. So it's got to involve tech. And I like to think that I'm moderately good at what I do. And I want to combine that with something, I don't know, something that I like. And so as I sat here and think about it, to me, the answer was obvious. It was pizza. I feel that if I can combine tech and pizza, that's my future. That's how I'm going to make it big. And, there's nothing unique about my love for pizza. I grew up in mid-Southern Illinois. I like Chicago-style pizza. I'll say that's probably my favorite at this point, followed by maybe a more traditional or New York-style. Living in St. Louis, they kind of have their own flavor of pizza, and it's kind of blasphemy to say that it's not the best thing ever, and it's really not. It's just kind of okay, but yeah, don't tell the other St. Louisans that. They might get angry. So if I were to combine my love of Chicago-style pizza and tech, essentially for me, it would be like combining Chicago and the tech savviness of Domino's, and we're gonna we'll have this Chicagonos concept. And if you haven't actually experienced the Domino's pizza app, it is actually pretty amazing. It shows you the status of your pizza, all the way from the time it's being made till it's delivered at your house. And so I'm going to hold that as, like, the gold standard for my business. Hopefully along the way, I don't break any patents or trademarks, but I'm more worried about being successful first, and then I'll let the lawyers, deal with the rest of that. And so, we're going to build this. We're going to build this thing from the ground up. And, as any developer would probably say, if I didn't create it, it must not be right. So that means I have to do, everything from the ground up. And so, what do we need for this pizza franchise? Well, we're clearly going to need users. And in today's world, devices, oh my goodness, could you imagine having a business and not supporting, like, every device ever? So we're going to need to support devices. Payments, if I couldn't accept payments, obviously I wouldn't be in business for very long. But I tell you what, this is one part of the system I have absolutely zero desire to write myself. Other people like Square have done this well. I'm just going to integrate with one of those things. Delivery, obviously we're in the middle of a pandemic, and those businesses that have delivery and have mobile apps are doing a lot better than those that don't. And then, the pizza. And given that I want to follow the Domino's model, I can't just have, like, a simple pizza oven. I got to have a smart oven. I got to know exactly where my pizza's at in the stage of development, and I got to know when it's done, when it's being delivered, when it's going to be at my front door. And so my system's going to have to combine all of those things. So, here I go, version 1 of my pizza shop. And I hate to say it, but I did it quickly because I'm creating a business, and I don't know if this is going to work or not. So I just slopped together everything I possibly could and came up with this giant monolithic app. And you know what? It works. And business is going great. People love my pizza. They love my apps. They love me. And to surprise to no one, this system is really brittle. If I want to add a new payment system, there's probably not enough days in the year, to be able to get that done. But business is booming. I've got capital, so it's time to reinvest, back into my business. So we launch, version 2.0. Now I have capital, so I can hire some really smart folks to help me, grow the business. And so, where am I at? I did some really good things now with this next version. We have microservices. We're using Kubernetes because it's all the hotness right now. Things aren't perfect with our system. We still have some apps that are kind of rogue and talking directly to our databases. We're doing some kind of sloppy things where we have a service that calls a service that calls a service. But, I can add features a lot faster than I could before. Things are definitely better, and business is still booming. But I don't want to stop there. I want to be the best. And one of the big problems with my model is that Chicago style pizza just takes forever. So it takes at least 35, 40 minutes to cook a pizza. And so, when you look at the number of hours that I'm open during the day, I'm probably not, efficiently or maximizing my potential. And so, I asked my team, what can we do to make pizzas faster? And so, any modern company now claims to be a data company. And that's what we need to be. We need to be a data company, right? So we need to look at all the things, all the orders, everything that we're doing, and we need to pull that all together and really do real analytics and predictive, pizza baking and whatnot. And then we can maximize things, and we could take over the world essentially. But when I look at the ecosystem of things that we've built today, getting that data is going to be really, really hard. So, with a microservice, a lot of times you have fit for purpose databases. So we have multiple databases. The data is everywhere. And sure, I can cobble together, some reports or dashboards, but it's not going to be real time. It's going to be, I'm going to have to constantly be asking my database questions like, how many pepperoni pizzas did I sell last week, instead of it telling me. And so that's, that infrastructure, all the decisions, though I've made them, they might have been the right ones at the time, they're kind of holding me back today. And we know we can do better. We've heard about this thing, this concept of data streaming. And then I know that Domino's is actually using it. I know that companies like Uber and Lyft are using it, and that's how they have their driver statuses. And I think that this is going to be a good fit for my pizza chain. And so just high level overview now, so Kafka was created at LinkedIn in 2008. I'd like to tell you that I knew all these people personally I'm going to talk about, but honestly, I just did internet research. The three founders are Neha Narkidi, Jay Krebs, and Jen Rao. So at the time, they were just regular software devs at LinkedIn, but they were trying to add a bunch of new features in a dramatic time of growth for LinkedIn. And as you can likely imagine, LinkedIn gets a whole lot more traffic than my pizza shop ever does or did. Today they're currently a top 25 US website, maybe as high as 16, according to some rankings. So I don't know what they were at the time, but you can imagine they get a lot of traffic. And so with that, what they were experiencing in 2008 was a lot of membership growth, where the site was becoming more complex and more interactions. And what they had built was, at the time, a reasonable approach where they were using REST layers probably to do a lot of these interactions. But they found that, the things that they had built REST for were really good for front end, interactions, but it really wasn't good for system-to-system interactions. And so when they came up with features like their news feed or other data-driven features, it just behaved a lot differently than like a traditional mobile or web consumer. And so during my research, I really liked this quote from Jake Krebs, where he says, very little data is batch in nature. Data in real life is not produced when the sun goes up or down. And when your business is digital, data keeps coming all the time. I think that's a really powerful statement that kind of helps frame, the mindset of what they were thinking when they built Kafka. So, they had a working system. They're using lots of known products that, that we all have heard of: ActiveMQ, Oracle, Hadoop, key value stores. And their system worked and it was fast, but it still had gaps. And so they took to making a new system, and they identified these 3 areas as had to have. So it had to be distributed. They felt that it'd be easier to expand and operate as a service. And then storage was a very important concept. So when you look at things today like ActiveMQ, if you have something that's working off of the queue and it drops offline, or if you want to add another thing to work off the queue, you can only read that message once. So there's no notion of being able to scale out by adding more work, right? You can read what's there and then it drops off the queue. So if we had this ability to store things, it gives us the ability to replay. It gives us the ability to fan out and add other pieces to our system, to catch up and do the work. And so that's a really powerful concept. And then, as we alluded to in the quote, not all data is batch. So there's this streaming concept, that less me asking and me being told or reacting, to data. And so then those 3 folks left to form a company called Confluent in 2014. Other quick notes, they actually made it into production. They made it into production in 2010. It became an official Apache project then, and then incubated until 2012. And then in 2014, the 3 of them left to form Confluent, and they are the largest contributor to the Apache project today. And there's some quick notes about, Kafka itself. So today, LinkedIn alone is over 1 trillion events per day. And then just here's a quick sample of, the industries that are using Kafka. So banks, manufacturing, telecom, insurance. Big thing is at the bottom, you can see that 80% of all Fortune 100 companies are using some flavor of Kafka in their system. So what I'm just trying to illustrate here is that, something that is relatively new to a lot of people is clearly gaining steam, in the marketplace. And so therefore, that's what the whole impetus of this session was just for me to, help maybe spread the word, or at least do a mild level of education or introduction, on data streaming and Kafka to others. So what we will do now is we'll just do some simple, Kafka basics. So what is data streaming? When you look at your data, it's just a different way to look at it. There's no beginning, there's no end. It's just a constant feed of data. So I'm probably pretty bad at analogies, but I think this one works. It's like water flowing in a creek. Sometimes the water is fast, sometimes it's slow, sometimes the creek is up, and other times it's almost dry. But the water is always flowing. Now, maybe the analogy falls apart a little bit during like a monsoon season or something like that. I'm just going to kind of hand wave and ignore that point for a moment. But there are 3 key concepts that we were going to talk about. That you'll see, like, all the things that I talk about after this really build on these concepts. So publish and subscribe. So I need the ability to publish data, events, these streams of data, and I need the ability to read these streams and be able to react to them. So that's the pub and sub concept. And then the storage we talked about. So the ability to basically capture those events and then persist them for as long as you desire. So is that, seconds, minutes, days, weeks, forever? To have that option is a very powerful one. And then this notion of process, which is really just simply, the subscribe action plus, the ability to act on it after you subscribe. So how it works, you have servers. And so the servers are responsible for, the stores that we keep talking about. And then there's this broker component. Ideally in production, you're going to have a minimum of 3 brokers. And then a cluster is a group of brokers. And then what you can do is you can have clusters, and you can have like a single cluster in your data center. You can have a multi-region cluster. You can have it in a single cloud, multi-cloud. You can have a mix of all of them. But, and that's for the resiliency, the high availability, all of the parts of the distributed system that they were trying to build out. And so then we have clients. So the client is, what we're going to use to read and write and process the streams of data. So essentially, a client is anything that connects to Kafka, right? And so it's not a part of the broker system. It's something that's completely managed. So a client is likely to be, your app or apps or whatever. But that's what a client is. And so you can see they've made the barrier for entry of working with Kafka pretty easy to start with. So they have client libraries that support all of these languages. A lot of them are the very common languages. Its roots really started with JVM support, but all these libraries today are owned by parts of the Apache project. So that's pretty awesome. If a new language were to come up, somebody would just need to put in a submission to get that language supported. And so you just wanted to point out, so we had the cluster and the brokers, but clients aren't a part of that, right? They're the things that are interacting with the Kafka topics and whatnot. And so you are responsible for managing and scaling those clients. And so it lends itself really well into working with like microservices or containerized apps. So I just wanted to call that out to make sure everybody understood that. So, an event. So we have the clients, we have the servers, the brokers and whatnot. So an event. And one of my teammates came up with this analogy. An event is a digital representation of something that happened in the analog world. So I really like that, right? So something happened. There's always a correlation of time to that thing that happened. And then there's data about that thing that happened that's very important. And so really just think of it as like a key value pair. So you have a key that represents the thing that happened. You have data about the thing, and then you always have a timestamp that goes with it. And so events end up on topics. So, a topic is a grouping of like events. And so events are organized by time. They're immutable. And the cool thing about a topic is you can have 0 or unlimited subscribers. So that's where it's different from like an active MQ type of scenario. So instead of a traditional queue where it comes in and you have one-to-one, I can have one-to-many. And so that's really some of the magic sauce there that helps us build these event-driven architectures, is that I can have this loosely coupled system where I publish one event and then several different things react to that one event. I'm going to have a high-level illustration of that just in a little bit. So we have producers and consumers, which is essentially just a client who publishes an event is considered a producer. A client who consumes an event or reacts to an event as a consumer. There is this notion of an offset on a topic. So we talked about the storage component and how everything is written and it's as permanent as you choose for it to be. And so when you add a client and they're ingesting data from a topic, there's this notion of offset. So you basically know how far back or forward into the topic they are. There's a couple ways you can deal with that. I think the default is that you let the server, the brokers manage that. You can manage it yourself. I believe you have to put some thought into doing that if you're going to do that yourself. So I think it's easiest just to leave the default setting. And then consumers, consume the data sequentially, based on the timestamp that they were entered into the topic. And then logs. So, I'm sorry, partitions. Partitions are topics that are split up across the brokers. So again, distributed, high availability. And I highlighted the distributed system because that, if you go back to the beginning with the three core concepts or the had-to-haves, distributed was a big part of that. And so, you can replicate for high availability and fault tolerance. You have to do that with a multi-cluster. Well, no, you can do it you can have multiple brokers in the cluster, and you can also do it across the clusters. So there's a lot of configuration that takes place, which goes into, there's a lot more to managing Kafka than what I'm talking about. There's many options. They're controlled by these configuration files. And I just covered some of the basics, so that way everybody had like a starting point to go from. So working with events, oops, right there we go. Your database currently stores the state of your data, but really all that data came from events. We talked earlier about how we try to represent the analog world digitally, and we've been doing that in databases for years. Thinking about like an orders table, right? So each order in the orders table really represents an order event with a bunch of data about that event. Customer name, what they ordered, how much they spent, all of that awesomeness. And then you think of other things like Google Analytics, which are a little more closer to a really true event system, because Google Analytics has been tracking clicks, scrolls, anytime I do really anything on a web page. And so they would capture each of those events and then some data about the user and when it took place. And other examples are logs from your Apache server. That lends itself really well to events. So we've been thinking about events for a long time. It's just that oftentimes we find ourselves taking it and then translating it into the database. So I think when we kind of make that realization, like we've been doing this for a while, I don't feel like the leap to doing an event-driven system is probably going to be that hard for a lot of us, because it's really pretty natural. So some observations about how a lot of us operate today. So direct transactional process. And I talked about this a little bit before in the example at LinkedIn, but this approach is pretty common, that, if you need data, we've got an API for that, right? So what's great about this approach is that, I explicitly fire off commands. I get, acknowledgement of the command, and then I either get data back or I get back an error result. If I'm using, REST APIs as an example, so I'm going to call a web service. I explicitly call the web service. I wait for the response, and I know I got the data back. And we see that with a lot of RESTful APIs, SOAP in the older days, but this is a pretty common scenario that we see today. And probably a bad analogy to make the point, but my dad was a UPS driver for a long time, and so I'd like to think of him as being like a strong guy. So he is responsible for making sure, you know, the packages got delivered. So like, let's say he's loading up the truck. So he's not a driver at this point. And so he brings this like 800-pound package, and he knows if he can get on the truck, then it should get delivered. But there's many things that he doesn't know. He doesn't know if the person who's like driving the truck is going to be able to like lift the package. What does he do if the truck isn't there? And so the analogy I'm trying to draw is that like when you're working with an API, you don't really know what it can handle or what to do. So what you find is you end up putting a lot of like guardrails in your systems when you're working with these APIs, because you just don't know much about them. I guess maybe you could argue that if you made them, you might know more about them, but you know, you don't know if you're handing that API the 800-pound gorilla payload that it can handle, or if it's going to be the one that breaks it. So you have to put things into your code to kind of guardrail against that. And you know, if you're working with an internet-based system, you're obviously going to put in some amount of reasonable guardrails, because you can't always assume the internet is up and running all the time. But just trying to illustrate that there are extra things that you have to do. And with this approach, you also have to note that you're really tightly coupled. And as a programmer, I've been trained for the last, I don't know, 10, 15 years that tightly coupling my system is a bad thing. You know, we have the dependency inversion principle that we try to follow. It's not a good system for like inter-agency or inter-application data transfer. You know, well, I'm not trying to say that we're suggesting you take a traditional web app and then you replace like a REST call with Kafka there. No, I'm talking about how, you know, oftentimes we create APIs that are going to be used for the web, and then somebody kind of, you know, bastardizes them to use them for like an internal, again, you know, inter-app dependency talking, and it's just not a really good solution. So another thing that we see is, you know, like the next improvement upon of that is probably message queues. So for to go back to the, you know, my dad working in the UPS warehouse analogy. So if we instead of him walking, you know, the boxes to the truck, if we put a conveyor belt in the middle, and then he can put the box on there, and there's some amount of trust he has to do, but the conveyor belt takes a lot of the heavy lifting off of his hands, right? The downside is he's no longer certain that the package made it to the truck. So there's a bit of trust there that he has to now have. But once that box is out of his sight, he has to, you know, trust that it's there. But it is a lot easier to work with. And this is honestly, message queues are probably how a lot of these large app-to-app integrations are probably working today, because you've added nice abstraction in the middle. We have the ability to add back pressure to our system, which is pretty awesome. You know, in the previous example, if we sent too many requests to an API, it could easily fall over. But with a queuing system, you know, they can back up until they're eventually, you know, relieved. Let's see. Now it works well for systems, but what happens when you want to do multiple actions, right? And so that is one part where this doesn't work well, is that if I want to do multiple actions off of the one thing, I have to, you know, create like a step functions or do some sort of like queuing thing where I go to one queue and then I go to the next queue to trigger the next queue to the next queue, instead of just being able to fire them off in parallel. So it works, but it may not be as ideal. And then also one of the big things is we can't guarantee the order, you know, or processed it in the way they came in. And so when we look at data streaming, the UPS analogy doesn't really work here. It's more like I don't know, I guess if you went into an art museum, you know, and you had a wall full of pictures, right? So I can go in, I can look at the pictures today. You can go in, you can look at them an hour later. Allison can go in and look at them 2 hours later. And as long as the museum wants those pictures up on that wall, they'll be there and anybody can come through and look at them as much as they want. If they want to expand the exhibit, you know, they can add another wall and then we can all go through and see the new things. And that's kind of how data streaming works. So, you know, we've talked about the storage component, how really important and powerful it is. You know, we're able to persist that data. We can have as many clients as we need work off that data. So my Pizza 2.0 plan, you know, let's say I'm actually collecting all the data that I wanted, and I'm persisting it for, like, let's say 6 months. And I finally come up with like a new data analytics, you know, engine that I want to throw on it. So because I persisted that data, I could throw that into my pipeline and it could get trained up. And as long as it needed to process that data because it was there and it was readily available. And then talking about one of the other big benefits is that order is guaranteed because the way Kafka works, you know, it's a log, it comes in, it's put in the log, it's ordered by timestamp. So we're guaranteed the order in that. So as awesome as it is, you know, there are some challenges with Kafka. And so we know it can handle like an amazing amount of data, you know, with the LinkedIn example and it handling, what was it, the trillion events per day. You know, if you are managing your own Kafka cluster, there is a cost to doing that. We saw that for production environment, it's a minimum of suggested minimum of 3 brokers per cluster for prod. But if you want, you know, even better high availability fault tolerance, you're going to want more clusters, right? So then, you know, all of a sudden the cost is me managing, you know, 3, 6, 9, 12 different boxes. And every time you have a box, you have to pay somebody to maintain that box. And maybe it's you or maybe it's somebody else, but there's a cost to that, right? So you have to weigh the decision of, you know, is the operational cost of the Kafka cluster worth the speed and agility gained in the application development or the feature development? So that's just something I wanted to call out, because unless you're doing a managed version of Kafka, you are going to have a cost associated with that. So just a quick illustration with my pizza shop to talk about, you know, or to illustrate what we talked about. So at the top, what I've done is I've, you know, essentially recreated some of the Domino's staging. So in this case, ordered a pizza, right? So the ordered pizza event, it gets written to the Kafka topic. We have a single topic per store in this scenario. And so it's written to the topic, and then, you know, my system reacts and I add that entry to my accounting ledger. So then that pizza is moved to the next station. Maybe I have magic buttons or some other way to communicate that up to people, but you know, now that the order is in and the dough has been made. So I'm sending an alert to the customer that says, okay, yeah, now your pizza is being worked on. So fast forward a little bit to, we're getting ready to pull it out of the oven. So you can see all the other events that have happened. In this particular case, so when I'm pulling the pizza out of the oven, I'm sending an event to, you know, the customer, but I'm also sending a note to the driver. So I'm starting to cue the driver to say, hey, we're gonna have an order ready for you here very soon, so get ready. And, you know, in the end, the delivery is complete. I close the ledger. Let's say I send a thank you email. I can do all kinds of things. So just, you know, a very simple illustration of how I can put something in the topic. I can have a single thing. I can have no things. I can have multiple things, but they all react to that being on the topic. So these are, the gray circles at the bottom are all clients that are subscribed to that topic, which is the store topic. But then really the power comes in is that this system is designed so well that you can have multiple events going on at the same time and it'll still work. So tried to color code. It may or may not have turned out well on your guys' end, but I just wanted to illustrate, look, we're firing off multiple events at the same time, and we could do this all day long, right? So we can keep throwing more and more simultaneous pizza events in here, and this system shouldn't fail. Take a drink for a second. So kind of the landscape of things. Who are the big players in this space? The Kafka platform, there's kind of two approaches. There's regular Apache Kafka, which is what most people use. It's open source. It's like the base solution for everything. And then Confluent is Apache plus some extra stuff. And we're going to talk about that in a couple of slides below. A couple of caveats around that are they give you a free version, but it's limited to a single broker. So it's kind of like they want to tease you with their features, their extra sauce that they put on top. So they'll make it free enough, but they won't really make it production worthy, And then let's see, the two paid versions. So one paid version is one you can run in your own data center on premises, and the other one is a completely managed SaaS offering. So, base Kafka is made up of these collection of APIs. So we talked a little bit about producers and consumers, right? So those are the APIs that a producer and a consumer talks to get things on a topic and then off a topic. And then there's the streams API, the connect API, and then the admin API. And so the streams API, it's a high level extraction created on top of a topic. In that, what they found was there's this like common scenario where people are they're grabbing data from a topic or topics, and then they're transforming it, and then they're writing it back to a topic. And so like that's sort of the sweet spot for streams, is they make that part a little more reproducible, a little more boilerplate-ish. And so that's where streams tend to fit in. They're used a lot for ETL type scenarios. Let's see. One thing or a couple things of note. So it's a part of your application. Again, it's not something that's managed by the brokers or the cluster. It's your app. So you have a Dockerized app. You have the case streams library in your app, and then you're managing and scaling that app and it watching of the topic. Let's see. Another thing to call it is right now streams, case streams is what they call it. That library is JDK dependent at this time. Let's see. The Connect API is the sister API or brother API, I don't know how you look at it, to that. So what's really neat about this is it is a kind of like another genericized framework to help write producers and consumers. So we look back and we had the list of clients and all the like starter kits that they had, the language support. And so those are great. That's for writing generic producers and consumer clients. But the Connect is maybe a little higher abstraction above that to make it even easier. So one of the neat things is it provides a specific area or format for doing transformations. So when you're thinking about ETLs, right, I have the ability to actually transform the data using that before I write it to a Kafka topic. And what's really powerful about this, about Connect, is that there's this like ecosystem of already existing connectors. So imagine being able to use one of these pre-built connectors, and I reduce the work of an ETL down to just writing a config file. Like that's pretty awesome. Like, I mean, I like programming a lot, but ETLing things isn't exactly the most sexy thing in the world. And so if I can have, for example, like a generic JDBC connector registered with the Connect cluster, and that's another thing to call out, is that we have our broker cluster. You have to have a connector cluster over here to run Kafka Connect. And so if I can just write a config file, register it with that thing, and then I magically get data moving from database over here to over here, like that's pretty awesome. And one of the key components is if you can find a database that supports change data capturing, then there's a good chance that you can really get the ETL stuff for free. So that is pretty awesome. So the admin API, I mean, it's exactly what you'd expect it to be. You can look at topics and brokers, and there's ACL, and there's other stuff. So not going to talk much about that. So Confluent Kafka, so it's like, what are the differences between Confluent Kafka and Apache Kafka? So it's everything in Apache Kafka plus some other things. So some really cool additional features. Kafka Connect, and really, I mean, it's in both of them. With the paid version of Confluent, you have access to, I think, 100+ pre-written connectors. So they view Kafka as this awesome data highway, and obviously they're incentivized, because they're selling services, to get people onto that highway. And so what they wanted to do is they wanted to lower the barrier for entry for getting people onto that highway. So they pre-wrote a bunch of connectors, like, let's say, Redis, databases, Salesforce, all kinds of things. So things that you and I might find redundant or hard, they've actually made pretty easy with these connectors, and that's pretty awesome. Schema registry is something that's unique to them. So we've talked about pubbing and subbing, but right now there's no guards around that data that's going in and out of the topics. And so schema registry is what does that, right? So you register the schema, and then the data coming in will be validated against that registry. You can do versioning as part of it. So that's a pretty cool feature. KSQL is really cool. So we talked about, let's see, so we have our pub sub, we have our clients, and so we talked about streams. Well, on top of streams, we have another abstraction, KSQL. So instead of writing code, if I could write SQL-like syntax to do the same thing as the code, that's pretty cool. So imagine that you push, I use Connect, I push data to a topic. I then have a streams app in the form of KSQL listening for that topic, or maybe listening to several topics, and it grabs it, it transforms it, and then it puts it onto a new topic, at which downstream I have another connector looking for that, reacting to it, grabbing it, and then shoving it into a database. So like, it's a pretty powerful workflow. And again, they're trying to really make that ETL process as simple as it can be. The big enterprise offerings, support is the name of the game. So we talked about how it's potentially pretty hard to manage your own cluster. And so, they want to take the burden of that away from you, or at least give you the support and confidence that if you don't feel like you know enough, they'll be there for you. One of the big new features that they're releasing with their Confluent platform is this concept of tiered storage. So, we talked about how storage is one of the big differentiators in their platform, but it comes at a cost, right? But imagine if I could use something like S3 and like their tiered storage concept, if S3 all the way down to the different Glacier, I could probably reduce my cost by quite a bit, and I can leave data persistence a lot longer. And that's that's one of the big features that they're working on. I don't know if it's released yet or if it's going to be. It's very, very near term. And then finally, security. So they've addressed role-based access controls with their platform. I don't believe that is in the Apache version. I don't know much about it, so I'm not going to go too deep into that. So just for you guys to know, out in the market, managed Kafka, Confluent has their offering. AWS has a managed Kafka service, so you can go, if you have an AWS account, and go stand that up. IBM, Heroku, and the others. There are definitely many choices out there for you to look at. There are some cloud similar technologies. So AWS Kinesis is very similar to Kafka, and out of the three, honestly, it's the one I'm most familiar with. So you can write stuff essentially to a topic. Kinesis is different, and I think it only has like a 7-day max duration. So you can't bring on a client like in my Pizza 2.0 scenario and have it retrain. So I think there are some other fundamental differences, but they're cloud native, and these are all managed by the cloud providers. They're very good. They do scale, but they are different. So my opinion, the probably easiest way to start is to probably get an account with the Confluent Cloud folks. You get a 3-month trial with like $200 off, unless you go crazy. And so you can use it and play with it that way. Else, you can download the Confluent platform free version. You can download the Apache version, but those are probably the easiest ways to kind of get your hand on the tech and start playing. And then, let's see, a couple of use cases to just help you maybe visualize where you could use this. So if you're familiar with kind of like, it's not really a design pattern, but it's like a refactoring pattern, the Strangler pattern. So, helping you to migrate, a monolith app to a microservice. If you have a database that supports that change data capturing we talked about earlier, what you can do is you can use Kafka Connect, and you can use a connector that works with that change data capturing. So you turn that on, and what you can do is you can leave your old system up, and you can have data feeding into it all day long. And then with the change data capturing, you can then in turn grab the data as it comes in and write it to a new database. Like let's say you're doing a Postgres that's fit for purpose, and maybe you're doing a Redis cache, and so you're building up your new microservice over here. So you have this plumbing in place that allows you to go from the old to the new while still keeping the old up. And then eventually what you can do is you can start to route all of the traffic away from the old and just directly into the new. And hey, I've already got Kafka topics set up along the way. So all I have to do is find the original source and then write to the new topics. And then there's a good chance that all the transformation along the way will cover it. So it's really not even that hard. In the spirit of microservices, we have to champion eventual data consistency. So if your topic pipeline is set up correctly, that shouldn't be a problem. We talked about API replacement earlier as an example with the LinkedIn and kind of like how that pattern falls apart. Don't create RESTful APIs to share with other internal apps and things like that. Use a topic. So there was a person that worked with us who talked about at his last job. People are always asking him for customized versions of his data. So instead, he just put it on a Kafka topic and said, here's my data. You grab it, you deal with it what you want. And it was pretty cool because then you could set up pipelines to then grab the data, react to it, transform it, and do with it as you want. ETL, so extract, transform, and load. Hopefully, during this time, I showed you that the tools they have created can really make this process very simple. So we're using this a lot on data warehouses that we're building for our clients. So I have data, in like 6 different places. I want to put it into a data warehouse. Well, I have, again, if I can use the connectors, it may be as simple as just a config file, and then boom, I'm starting to ingest the data. With streams and KSQLDB, I have a middle section there to where I can transform the data, join it from different sources, and get it to what I need. So it's a really powerful use case for ETL. And then, some other examples, real-time applications. Hopefully that's just evident with the eventing paradigm and then kind of the little illustration I did, but you can really do eventing real-time applications pretty well. Microservices, that's a neat one. So essentially what they're promoting is that you could, your service could, using case streams or other things, could talk to a topic and then just react that way. Customer 360 plays a lot into the data warehouse, kind of space where I talked about the idea where you have data all over your workplace, your customer's workplace, and you just want to wrangle it and put it into a central location. Kafka is a great way to do that. And then IoT, if there's one thing that this could definitely be made for is IoT. When you think of the millions or billions of devices out in the world and how they're all chatty, this platform can clearly, handle that. So wrapping it up, I am by no means an expert, on Kafka. I learned about it for the first time like 4 years ago. There was a large project. It was actually a customer 360 type project where we were doing a lot of data wrangling, and we were building a master data model. And so, my goal for this talk was to kind of give a 100 level introduction about Kafka, to introduce you to the concepts of, event streaming, and give you some illustrations on how it could work and maybe some use cases to where you can maybe leave this talk and think of how you could apply it. I have folks on my team who are definitely more of those 304 level experts. So if you guys have any really hard technical questions, I will probably have to defer to them. But with that, early on, I showed you the slide of the market adoption, and honestly, we're seeing a lot of it too with our customers. I think I've had 10 plus opportunities this year where clients have saw a need for doing this, and some of it's around data warehousing and other parts about other initiatives they want to do. But the key thing is they all want real-time information, and they believe that this system, this setup is what will do that for them. And then one of the 300 and 400 level guys on my team, Brian Kohler, so he wrote a nice blog article on our company's website called "The Need for Speed, Leverage Real-Time Data on the Fly." I thought it was a good article. It gave a really nice layman's explanation of data streaming and whatnot. And obviously, there are all kinds of things that you can go out and read on the Confluent blog or whatnot. And what talk wouldn't have the obligatory, I work here plug. So again, it's in St. Louis, but we have remote working everywhere. I like it. It's a great place to work. We're, I don't know, a medium to large size company. It's kind of funny because we started off so small, but now we're a little bigger. And really, there's pretty much a job for everyone. We have app developers, we have QA teams, we have project managers. I'm a part of the cloud practice. We have a separate big data and AI practice. So it's a great company. Couldn't say enough about it. And then wanted to promote my colleagues who are also speaking here. So a lot of them have already actually spoke today. Allison, Jeff, and John have all spoken. I believe Kevin's speaking tomorrow. So if you get a chance, attend their sessions. And then can't say enough without the sponsors. Without them, we wouldn't have a conference. So with that, thank you for attending. Hopefully I didn't talk too fast, and hopefully you learned something.
Thanks, Eric. You did good.
Thank you.
Okay, there's a question from Jody Caldwell.
Okay.
Jody said, using your example, there is a dedicated system to contact drivers to pick up a pizza for delivery. Does this system subscribe to topic store _123 and filter the events down to the one it's interested in, i.e. boxing done, or is there a way to get just the boxing done event that it's interested in?
So the way I had it shown, you're absolutely correct. So all the clients were basically ingesting each message and then filtering for what they wanted. What you could do is you could chain a series of topics and then filter it to just a specific topic, right? So, you know, I had it basically as a state, and so each client was looking for a certain state for the event that was on the topic. But really, another way you could do it is you could take and you can make each state its own topic, and then you can move the events there, if that makes sense. And I confirmed with the 300 and 400 level guys, and they said the way I had it drawn is the way they would do it. So it's interesting, but I was like, okay, are you sure? And they're like, yes, absolutely. I'm like, all right, I'll trust you guys. You're the smart ones.
Jody said, okay, thank you.
Thanks. Well, is that it? Is it over? Are we done?
We have another question from Jody.
All right, hopefully I will answer it. No, you're fine. Totally. I flipped over too, so now I can see it, Allison. Thank you.
Sweet. My job is done. I didn't even need an OI.
You had a great OI, though. I will give you that.
And then there's the creepy whisper.
Don't bring that back. Leave it. Leave that one alone.
Behind you.
If you can't tell, I've known Allison for a while. So are you talking about, when you talk about you would not use REST APIs for data in favor of using Kafka, would that apply even if you only had a single subscriber? Man, I'd have to think about that one. Okay. We're gonna workshop this. So I have a single, and so I'm gonna use okay. If only one app is interested in your events, probably, well, I guess it would depend on scale. So we talked about the pitfalls of the API and how, you know, eventually it will hit a level that will break. You know, with Kafka and the message queue, you had the concept of, you know, not backing off, but I'm drawing a blank now, where you know that it could handle back pressure, where you could handle it, right? So eventually an HTTP server, you know, could fall apart. Now I guess technically I could use, like, let's say Amazon Fargate, where I have containers and it's like set for Uber scale, and then maybe that would never fall apart. But with that would be a cost, you know. But if it's a once in a lifetime type of event, I'd probably rather do that than use Kafka, is my thinking. I don't know. I'm kind of rambling, but is that helping you? Because there is a lot of overhead to running Kafka. Yeah. They have different types of, you know, like certifications for Kafka stuff. So they have like a developer certification, they have an operator certification, but it is expensive. And so, you know, what we found is that a lot of our clients, they want the awesome tech and they want the features that come with it. They don't want to hire the people to run it. And so they're almost all in favor of using something like Confluent to just like, here, just take my money and take care of this for me. We just want the delivery of the apps. So it's fair. I get it. But yeah, Jody, for your situation, if you're using like a real cloud environment, Kafka is probably overkill. I know AWS better than the other two clouds. And so probably something like SQS would be a good, you know, SQS and SNS would probably be would probably be good for you. Yeah. Any other questions? All right. Well, thank you for attending and listening. Hope you enjoy the rest of your conference.